Good morning, everyone, and welcome to part 2 of my Machine Control Studio software training course. Let's see here. Today, what I'm going to do, what I'm going to do is I'm going to start where we left off yesterday. I want to finish off that ladder diagram program we started. So that's where I'm going to start, but then after that, I'm going to go through and we'll look at some project properties, some more things, tools that you may or may not be aware of with Machine Control Studio. We'll look at properties, we'll look at the options dialog. Then we're going to learn about the library manager and the task manager. And then after that, I'm doing the ladder diagram example right now, and I'm going to show you the structured text today. We're going to work a little more with structured text. So the goal today is the project we started yesterday. I'm going to show you, we're going to add 2 more tasks. We're going to add an initial task and a position task. So let me begin with how we left off yesterday. Let's go here. Where are we? There we are. So here's the goal. This is what we wanted to do with our ladder diagram. So we got the first line done here. We got that part taken care of yesterday. So now I'm going to carry on with the rest. So I'm going to add another network that's going to, if the SafeTorque contact is closed, then I'm going to enable the drive using menu 6, parameter 15. Then I'm going to add another network that uses a move operator, which you haven't seen yet, to set preset speed. Yesterday I showed you my Connect setup, and the way I've got my demo drive set up is it's set in preset speed mode. So I'm going to add a network that's going to allow me to move a speed into 121, which is preset speed 1. Then I'm going to create a virtual start push button. And as long as the SafeTorque off is closed, I'm going to run the motor forward. So that's the goal for today. So let me flip over to Machine Control Studio now. There we go. So here's where we were yesterday. This is kind of debatable. I don't know if that symbol comment is really useful or not. It could get to be a lot and could make your programs a little hard to read, but just so you know, I'm just going to leave that stuff in there for now. And when we get to the options discussion later, I'll probably disable the symbol comments and just use the regular comment there. So that's the first network. If the SafeTorque off is closed, that's a hardware switch, I'm going to turn on menu 6, parameter 15, which is software drive enable. That's not technically what it's called in the software, but that's its purpose. So now I'll do something. I'm going to add a new network, and there's different ways to do this. Once again, right-clicking comes into play. So I'm just going to right-click there, and I'm going to insert a network. If I insert a network, it's going to append the network. It's going to put it above the currently highlighted network, but I want one below. So I'm going to go like so, and here's my new network. And remember again, yesterday I went up to the tools and the options, and I said that now the default configuration when I add a network is to have a contact and a coil. If you remember, when I started yesterday and before I enabled that option, all I got was a blank line. So now it looks a little more like a traditional PLC program. So what I'm going to check for now is, as long as this is on, I want to turn on, as long as that is on, let me see, what was my goal? That we did that. Okay, we did that. And now I'm going to use a move operator. That's what I'm going to do. Okay. So here, what I'm going to do is I'm going to show you something new. The other thing I touched on yesterday, but notice now that I have a ladder diagram as my implementation language, I get tools over here in my toolbox. And the tool that I want to use now is one of these other operators. So you see other operators, math, Boolean stuff, function blocks. There's some timers, time on, time off. There's a count up, count down. So now that we're using a implementation language that supports tools in the toolbox, well, there they are. So now to use a move operator here, what I'm going to do is I'm going to just click on that and I'm going to drag it onto the canvas, which is what this is called. And again, if you have really good eyes, I suppose I could zoom this in. Why don't I do that? All right, so I'm going to come in here and I'm just going to blow that up a little bit. Whoop. Okay, so let me move back over here. Okay, so here we go. I'm going to grab this move, and when I drag it onto the canvas, you see these little green diamonds that show up? Those are legitimate places where I could drop this function or this operator. So what I'm going to do is I'm going to drop it right there. And the way the move operator works is it's going to move this to here when it's enabled or when it's true. So what I'll do is the enable for this operator, I'm going to associate that with the drive being enabled. As long as menu 6 parameter 15 is on, that's what I'm going to do. So let me slide over here. Oh, too far. I guess that's a problem. So I'm going to use this now as a contact. So I'm going to right click on that and I'm going to copy that. Then I'll come over here and paste it just like that. Right? So now, as long as the drive is enabled, I am going to move a value of 100.0, because that's what I wanted to do. I'm going to move that to menu 1 parameter 21. Now, what you're going to see here is something else that's very important. So I'll use the input assistant again. Click there. There's my variables. So let me move up. This was menu 6. I want menu 1. Now what I want to point out to you, you notice raw, that word raw there? Parameter 21 has two different versions, a straight version and a raw version. Well, what does that mean? It means that parameter 21 can be written to as either a long real or a double integer. So what this is saying is if you would like to include a decimal point, which I do, as part of your entry, then I'm going to have to use the long real. If I wanted to enter that as an integer number, then I would have chosen to use the dint value instead. That's very subtle, but that is very, very important. And we're going to talk more about data types today. Machine Control Studio / CodeSys is very sensitive to these. So I'm going to choose that. I'll just double click, enter. There we go. So I'm moving a value of 100 into menu 1 parameter 21. And now I'll slide over. And the coil on this network is going to be menu 6 parameter 30. How do I know that? Well, I'm not trying to be smart, but it's just because I know that that is the run forward. It's a sequencer operation. Ordinarily, if we're just using the host drive as is, menu 6 parameter 30 might be assigned to a digital input. It's run forward. So I'm using Machine Control Studio to do the same thing. So again, I'm just going to type menu M06 dot. And now that opens up smart coding is what this feature is called with dot notation. It's smart coding is enabled, so I see this. If you don't see this right now, don't worry about it because I'm going to show you how to turn it off and turn it on. So there it is. Run forward. There we go. Right, so as long as the drive is enabled, it's going to be updating menu 1 parameter 21 with a value of 100.0. Right, so now the next network we're going to add is my virtual start push button. So I'll right click in the margin, insert network below. So now what I'm going to do is I'm going to click there, but because it's going to be a user push button, I'm just going to say my start push button. Now when I enter that into the network, the auto declare comes up and says do tell what's my start push button. Well, it's going to be a local variable for now. There's my name, and it's a Boolean data type, meaning it's true or false, right? And I'll talk more about Boolean data types here today also, because other software that I've used with a Boolean data type, you can change state by using a 0 or a 1. Not so here. With here, it's a Boolean data type. It must be on or it must be off. So we'll talk more about that. Now, another thing I'm going to do that I didn't do yesterday is I'm going to put a comment here. If I could spell correctly, this is a start push button. Now, the reason I do that is watch what happens when I add this to our variable declaration area. You see that? We're also going to be talking a lot about comments. Comments are very important, right? So this is a start push button. So you see it up there, but then if I hover over this, or I see the comment there too, but if I hover over it, you can also see that comment. So that's important as well. Right, so okay, there's my start push button. Now let's go over to the coil. There we go. So once again, I'm going to take a function out of menu 6. So I'll use input assistant just for fun. Menu 6 parameter 30. Whoops, that's not menu 6. That's menu 1. There's menu 6. Right, there it is. Double click, enter. Okay, so I'm going to zoom back out again. There we go. So here is my project. Right? So as long as the button, oh, I don't want to do this. Oh, I'm sorry, I made a mistake there. Got ahead of myself. That's not good. I don't want to do that at all. Sorry. I want to do it there with my start push button, but yeah, well, I guess I'm kind of glad I did that, because now I'll show you something else that separates this from a kind of a traditional PLC. I'm going to right click there and delete it. Okay. I don't see any squiggly lines. I don't see any errors here. That is an acceptable network in Machine Control Studio. I don't have to have a coil as the last thing in the network. So to verify that now, I'll come up and we'll build the project. We'll compile it and check for syntax errors. So I'll come up to build, build. Okay, 0 errors, 0 warnings. That's what we want. All right, now I'm going to transfer the code down to the MCI 210, which is on my M700. And I showed you this yesterday with the emulator, so we'll go through it again today. That process begins from the online menu, log in. Okay, so it says there's already in run mode, there's an application, so just like home, just say yes and carry on. So now it's transferring the code down to the MCI 210. And now here we are again, right? We have my program. I am online. And how can you tell you're online? You can tell you're online because the active device will be highlighted in green, right? And the ladder diagram changes a little bit too. So I'm going to start my program now. It's stopped. So I'm going to come up here and start it. And now let's just operate it. So I'll come up here. I'm going to switch views and show you my demo here so we can show you I'm not faking it. So it says if the safe torque off is closed, we're going to enable the drive. So let's try that. There. So you see now, in terms of what happens when you're online, by default, active network components and networks will highlight in blue. Further, if you come up here to your variable declaration area, now you can also check the status this way, right? So my start push button, well, it's off right now, but I'm going to turn that on now. And how do I do that? Well, to force a value, there's different ways of doing it. What I like to do is just double click on it. Now you see that? It changes to true, but nothing has happened. You don't see my motor running, right? So to get that to right, there is a menu item here called, in the debug menu, called write values. So I'll just do it this way, but there's an important keystroke that you should write down. To force values, it's Control and the F7 key. Right? So my motor's not moving, so that would lead me to believe, in fact, now that I say that, my drive is not in preset speed mode. My bad. Let me go change that. So let me turn this off. See how it changed to false? This time I'll use the keyboard. Control F7. Let me go up and make a quick change on the demo. I'll just use Connect to do that. All right, let's go here. Let's launch Connect. Okay, I have a question here. Yes, Alex. No, the emulator won't let you perform actual drive code. You know, the emulator can be used to check non-drive related things like your math and things like that, logic and math, but it doesn't have anything to do. It's not a drive processor emulator, so no. All right. So let me go online. Let's see, is it this one? Yeah, let's see. Is it that one? That's probably it. Yeah. Okay, so I'm going to put the drive into preset speed mode. And that's in menu 1. Oh, it is in preset speed mode. Okay, I gotcha. So it is in preset speed mode. Oh, all right. Yeah, I have the AMC enabled, so let me turn that off. That's why. Like so. All right, now we'll try it again. Okay. All right. Now this time I'll use the prepared value column up here. If I double click in that column, I can toggle through. True. There we go. Right? Well, I guess that's an important thing to note too. we are going to be using the AMC, but when you enable the AMC, the speed reference comes to what's called the hard speed reference, which bypasses the internal drive acceleration menu and things like that. So that's why I had to disable the AMC to get it to run in preset speed mode. So there we go. Now it's running. Now I'll stop it by turning that off. Like so. So, the takeaway. Remember, when you would like to force things, or you'd like to update, I suppose force isn't a good word, when you want to update the status of variables when you are on read-write variables when you're online, you can use the prepared value column here, or you can double click here. So I'm going to go offline and we're going to modify this now. So I'm offline now, which means I'm able to edit this program. What I also would like to show you at this point is I am going to replace this constant with a user variable. So instead of writing a constant, which isn't very practical, I'm going to double click there, or just click there, and I'm going to change this to read user speed instead. When I hit enter, I'm going to get the auto declare editor again. Now, the data type here is integer, which means that I can't write a value here to that includes a decimal place. So what I'm going to do is I am going to change this from int to lreal, like so. And I'll say this is the user speed, like that. And I'll click OK. No squiggles. Now, and why did I do that? Well, because I'm not using the raw version of that parameter, right? So that's why that has to be an LReal as well. So I've made a change now, and I'm going to check my syntax, build. Now watch what happens when I log in this time. Well, I'm purposely going to make a mistake just to show you. I'm going to say online. Okay, so far so good. You can't log in and download code while the host drive is enabled, which mine is right now. So let me flip off the enable, safe torque off, and retry. Okay, there we go. My program is stopped. I will start it. All right, now I'm going to update user speed. All right, same way we did before. I'm going to double click right there, except now that this is not a Boolean data type, now I get prepare a new value for the next write or force. So I'm going to make it 500.0. Now it hasn't taken effect yet, right? You see it's within the carets there. So to update it, I'm going to say Control F7. Now it hasn't written that value here yet either. See that? That's the actual value. I'm online with the drive right now. Well, that's because this function or this operator is not enabled. So there we go. And you see how it updates. So I'll come up to my user speed or my start push button. There we go. Right? So I can update this now. I can update that following the same Control F7. That kind of editing you can do while you're online. So I will stop it. And there we go. Now, as I touched on yesterday, these ladders, these networks, can be as complex as you need them to be. So before I get off of ladder diagram, let me add some elements to it. So I'm going to log off, disable the drive because I can't download changes. So I'll come up here now, or I'll come down here. Now what I'll do is I will add a parallel contact. So I'll add a negated contact below. So how did I do that? I clicked on the contact under which I wanted to add a parallel contact. So what I'm going to do here is I'm going to say I can start it, right? Let's see. And I'll just make my stop push button here too. So I'll just say my stop push button. So that's another user variable. I'll click OK. Just like that. Now, if I wanted to add things to this network or to this parallel branch, I can come up and add contact to the right. So I can extend that So again, these networks can be as elaborate as you need them to be to get your functionality correct. Okay, so here we go. I'm just going to come up, and this time instead of using that, this from the toolbar here is the icon for build. So I'll click that. Good to go. And also, instead of online login, here's the icon that does that, login. Yes. Okay, there we go. So you see that's examine if closed, so it's true right now. So I will start my program. Right? So I need to change the status of that. There we go. Now I'll enable it. Because and this is another important concept too. It's pretty good it's working out this way. Because I did not set an initial value, there's a good example of what the initial value is for. Because I did not initialize this variable to a value, well, it's going to always begin at 0. That's very subtle, but you need to be aware of that, particularly in a quote-unquote real application. This program will automatically start on power cycle of the drive, the host drive. So, you know, if you do a reset, if something like that, a trip on the drive were to occur, unless you initialize these to something real, and I do not recommend initializing to 0 either, particularly if you're using variables in mathematical formulas, you'll end up with a divide by 0. So you need to be careful with how you initialize these things. But because I didn't, I'll come up here and put something in there. Something like that. There we go. So now it's running. Well, that's not a very good, yeah, it's probably a good time to tell you I'm not the world's best programmer either, but I hope you get the gist there. I have to turn off my start. There. So the point being that using the branching tools up here on the toolbar, you can make these rungs as elaborate as you need them to be. And I will be showing you more examples when I show you my final project PLC program where I use branching quite extensively. So, all right. We'll log out of there. I'll turn that off so we're not quite so noisy. Let me switch over here. And let's get back to here. Okay, so let's start there. Let's start here. Project settings. Does anybody have any questions about what we have looked at so far with the ladder diagram and things like that?
So I have a question. I did start the emulator, and I tried downloading. I didn't realize that we couldn't emulate the motor stuff.
Okay.
Before that.
Uh-huh.
But my freewheeling program in the devices is blue now, as opposed to black like the rest of the texts. But I don't see anything that tells me what that means.
Oh, well, let me flip back over there. Okay. So
yours is black.
right here?
Uh,
Yeah.
Up above under Library Manager.
Oh, this?
Yes. The text is blue now.
What version? I guess I'm not entirely. So did you start the emulator or not?
I did start the emulator, yes.
Okay. I think that's an indication that you can't execute drive related. I mean, does your program, did you do this? Follow along with me?
Yeah, I
Yeah.
got everything followed along, yeah.
Yeah. See, I think that blue indicates that you can't execute drive related functions with the emulator as your device.
Okay. All right. That makes
Right.
sense.
Yeah. Now, having said that, and I will look into this, I believe there is a library of emulated drive functions also. I haven't used it personally, so I really can't comment. But anyway,
Okay. Thank
so
you.
yeah, you can right click and stop the emulator, and yeah, unless you have hardware going forward, it's not going to be practical to do anything with that. So, all right, any other questions, or can I move along here? All right. Well, let's go back here. So now I want to look at project settings. Okay. So you can access project settings from the POU tab along the left side of the screen. So let me show you that. Right. So down here, we have devices, which is what I'm looking at now. Here's my devices, but here's POUs. And there's project settings. So if I double click there, here are my project settings. Now, some of the things that are important here are security. The Machine Control Studio / CodeSys has a very strong security system. So if I come in here and I look at security now, here is how I can. No protection means it's wide open. Encryption now, what that means is I could encrypt it using a password, right? So if I didn't want people to look at my code, it's there, but I can't edit it, I could do that. I am not a fan of passwords. Mainly because when you password encrypt something, you're locking people. That means you're the guy that's going to get all the phone calls at the end of the day, right? So if you're an OEM and that's what you want to do, that's one way of keeping people out. So that's your security tab there. Now, sequential function chart, right? Here, the project that we are doing, or the final project that I am going to show you, contains some system variables that are specific to sequential function chart. This is the place where you can go in and selectively enable system variables that relate to sequential function charts. So I will explain more of this on tomorrow, but let me show you what's there now. So you don't know what a sequential function chart is at this point, so it doesn't make a whole lot of sense to you. But one of the things with a sequential function chart is once it starts running, once you start it, yes, I can branch, yes, I can do other things. But what I can't do, unless I enable some of these system variables, is actually stop the sequential function chart. So my final project, I have SFC init and reset enabled. And I'll show you how those work when I demonstrate that project. But if you're intending to use sequential function chart, some of these variables, system variables, will be quite handy. So that's the sequential function chart tab. Source download, here we go. That's also important. Source download. So the first thing is timing down here. So what it's saying is, when do you want to download source code? Well, implicitly at program download and online change means every time you log in on online login to download, it's also going to load the project archive into the source or into the active device, right? So implicitly at creating boot projects. So if I were to come up here, well, I can't now, but if I look at the build menu, you'll see create boot project. Well, if I trigger it up here and I have that checked, that too will download the source archive to the active device, and so on and so forth. I have elected only on demand, right? Because I don't want to waste extra time and waste bits coming back and forth until my program is debugged and ready to go. So I will ultimately download source code, but only when I'm ready. So that's why I've chosen only on demand there. Now, another thing you can do is additional files, right? So if I click there, one of the things that I do is reference libraries, right? And I'll talk about this a little bit more too. I think tomorrow I'm going to get into how do you share your projects with other people. One thing that's critical is that your project contains, if you're sharing it, contains the actual libraries that you reference during the creation of that project. Otherwise, the end user might have an older or newer version of Machine Control Studio, and they'll open up your project and they'll get 7,000 errors down here when you're making references to libraries that they don't have on their system. So we're talking about libraries today, but know that that's what I generally will do. Now, static analysis light. Now, that doesn't really make, it's not very intuitive, in other words, as to what that means, but I'll tell you what it means. Here, static analysis light. What this does is unused variables. That's really useful. By the time you're done debugging your projects, unless you're really good programmer and you can get rid of all your unused variables, I can't. I'll have a bunch that I've used for debug or whatever, and so I'll check that. And then what happens when I go online log in, before it downloads, it's going to come up and say, oh, okay, you've got these unused variables. Shall I get rid of them? And yes, I'm not using them, so why clutter up the machine? So static analysis light, I don't know where that comes from, but that's what its functionality is. Yeah, and users and groups, again, when it comes to security here, I don't know if there's any Linux fans out there, but if there are, this is very much, or the CodeSys security system is very much like Linux in the sense that you have the concept of super user, you, the owner, and then you can create groups, and each group can have a permission. A member of a group can have separate permissions from the owner of the group, and it can be pretty involved. A practical example would be, I'll have a group called engineers, and they'll have full access to every part of the application. I'll have a group called maintenance, and they might have selective access to some things. So that's the concept of users and groups, and it's quite powerful. And in fact, if you'll recall, when I come up to online login, well, that's what it's talking about. I'm logged in as the owner, but if I say online login, before I can transfer, it's going to want me to log in so that the preferences or my permissions from this field will go into play or will come into play. And if I'm not authorized to do the download or whatever, or edit anything, it simply won't let me. So this is pretty involved. We're not going to go through the whole thing, but hopefully with that you'll have an understanding of just exactly what that is. So that's the properties field. Project settings is where that is located on the POU tab. Now tools, right? So we looked at this briefly yesterday. We were here with the function block diagram, ladder, and instruction list editor. But the thing I want to point out here is smart coding. This is the reason when I put in M06 dot that I get anything to show up. Smart coding permits the use of dot notation as what's called a deconstructor. So, for example, and this is a kind of a carryover from a traditional PLC too. If I have a timer called my timer and I want to get at the output of that timer, I can reference it using dot notation, my timer dot Q. Q is the output of the timer. So unless smart coding is enabled, you won't be able to do that. So I believe these are the defaults, and that's what I do, but let me just double check to make sure. Tools, options, smart coding. Yeah. There we go. I'm going to turn this on list components immediately, right? So that's the only change I will make there. Namespace can be kind of annoying, honestly. Namespace would include the name of the menu that your particular parameter came from. So I don't find that to be tremendously useful, so I just don't use that. But make sure that your smart coding is enabled. And you see a lot of other things in there too, in the options when it comes to smart coding. You can go up, these are all the preferences for the visual languages. But if I go down now, text editor, if I don't want the colors the way they are, if I don't like the fonts, what's dark look like? Yeah, so now you can look like a, kind of a hacker person with a dark terminal there. So I'm just going to leave it at the default. But understand this is where options for CodeSys itself lie. Now, the other thing I'll point out is international settings. Check this out now. I think it's going to load some libraries here. There we go. So now look at that. Espanol, French, Italian. I presume that's Chinese or Korean, one of the two. But you can actually change the language for the integrated development environment into, well, let's see what happens. Espanol. Well, I probably don't want to, I'd hate to crash this right now, but that's the function of that. Or actually, same as Microsoft Windows. That's probably a smart choice. So whatever your computer's using, well, CodeSys will too. So there are some really important things in here in the tools options diagram or dialog box. Now let's look at libraries, and specifically the library manager. I touched on this just a little bit yesterday, and we've been pulling parameters out of the CT Uni M library. So now let's go look at the library manager. One of the very powerful things that you can do when using Machine Control Studio is you can create your own libraries. That's really, in my opinion, a very good argument for why would you use CodeSys Machine Control Studio. If you're an OEM, or if you work on machines or develop machines, kind of like Shorewood over there, Jack, what you can do is you can build your own libraries that contain function blocks, functions, POUs, any kind of POU that you have created. And then you could simply import that library into your new project, and boom, you'll have access to all of the things that you included in your library. So rather than having to cut and paste and, that sort of stuff, you just develop your own library and just reuse it. Code reusability is one of the best features of this software, if you ask me. So let's go look at that. Where is that? Well, that's going to be on the Devices tab. And here's Library Manager. Double click. So what you see here, these are the libraries that were included when you installed Machine Control Studio. So libraries live, quote unquote, in the library repository. So the location of the library repository is here. I do not recommend changing that, okay? But what you can do is you can install new libraries, right? So if you have a library that you've created somewhere or you've downloaded, this is CodeSys. So there are places that provide open source libraries for CodeSys. A lot of them are free, and you can just download them and you can install them using this method here. Now, would it make sense to download a library from a Wago PLC to include in ours? Not so much. It just depends on what it is. But anyway, this is where libraries that you see here come from. So if I wanted to begin, let's just look and see what's in some of these menus or libraries. So I'll click there. Oh, okay. Look at that. There's some utilities. What is this? I don't know. Let's click on it and find out. So documentation enables freeze offset catcher for the P1, P2 interface, right? So there is an inbuilt function. It's a function, not a function block, that does freeze for you. And so on and so forth. So to see what's in these libraries, you just click on them. There's that. Oh, CT Advanced. Let's look at that one. This one, the advanced libraries, if any of you are familiar with our SIPT programming tool, there was a whole slew of function blocks, functions, and code that were developed for SIPT that have now been ported into Machine Control Studio. Well, this is where those functions and function blocks are found. So if you have used SIPT in the past and you're wondering, gosh, where can I get my, let's see, what do I have here? Moldive or one of those older functions, math. Yeah, popular one is this Moldive right here, multiply, divide. So that, or and actually there's some cam in here too, I think, right? Yeah, so there are a lot of position control. There's cam box, yeah, right. So that is used to create a cam profile, and there's a lot of useful things in there, and those come from the older SIP software. So if I want to add a library, so if you'll remember when I looked at the system repository, these are the things that are found in the repository right now. So if I go to advanced, it gives me the details button, which I like. Now, if you create your own library, it's going to be found here in the miscellaneous library. So these are libraries that I've created. So here's one called AMC function blocks. So let's look at details. Right? So if I look here, there's a function block for an absolute index that I built. Right? And here's the documentation for that function block. Now that didn't happen automatically. I had to add those, and these are actual comments, just like I showed you a little while ago. So comments become documentation. Yet another good reason to use comments. That's what it looks like graphically. So pretty handy library. So I'll just add that. There it is. Right? So there's my library up there. And just to show you that that works, I'll come in here. Now, this won't make any sense, but I will insert a network below. And I'll come up now. And to use that, I'm going to come up here. I'm going to click on the network. And notice when I do, just the network, not the contact or the coil, this is the network. Now I get these, insert box. So I'm going to insert a box. And here's the boxes I can insert. Well, there's one. Boom. Right? There it is. So that's what the library manager is used for. It's adding things to your application, or if you'd like to know more about what is available to you, you do that in the library manager. Does anybody have any questions about that?
I see that does not, it doesn't look like it's on a ladder rung. Is that not supposed to be?
It is. It doesn't have a line here because all I did was just drop it right in the box. I just dropped it right on that network, right?
Okay.
So yeah. Yeah. So if I would have dropped it to the right of that contact that was on there, it would have showed up. It had showed the rest of the network.
Oh, okay.
All right. Any other questions? If not, let's go ahead and take our break, and I will see you at 11:10. There we go. So, libraries. Very fundamental part of Machine Control Studio. Again, the key here is creating your own reusable code and then storing that into a library. I will be doing a more advanced Machine Control Studio course at some point, and I will show you the process for creating your own library. It's not difficult by any means, but I don't have time to get into that now. So the library manager, we just talked about that. And again, one of the reason this slide is here is data types. If you look at the documentation for the CT-UNI-M library, which is where I've been pulling a lot of the things that we've been demonstrating so far, there's a column in the documentation tab that shows the data type. And when you're working with variables and drive parameters and perhaps doing math and things like that, the data type of the parameter that you're looking at is critical. Now, not to say that if there's a lot of data converters that are included in Machine Control Studio. So, if I were to look here and I'm just going to get rid of that for the time being. We'll delete that one. But if I wanted to, for example, I want to click here and I'm going to put a normally closed contact there. So I'll come in here just to open the input assistant. So CT-UNI-M, there we are. So let's have a look. So I don't know, let's go to, let's look at menu 1, let's look at menu 2. Right, so what is all this stuff? Let's look here. Right, so that's where I pull things from, but if I want to come and see that documentation, that's here in the library manager. So there's the library manager, and we have user programming, CT advanced, cyclic length scheduler, CT standard, device parameters, host drive parameters. There it is. Right, so menu 2. Right, if I come in here, these are all things that don't have documentation, of course, but properties, that's the namespace, things like that. So the data typing is very important, and you can change the data type using data conversion tool. There are a lot of them. So I'll go back to my program here now. Got a squiggle. Well, that's because of this. So I'm just going to right click there. And while I'm here, as long as we're talking about ladder, again, right click. So you see here, this is where I can negate. See, I changed that to examine if closed. Edge detection, positive edge. And if I double click, it's going to change here, right? Well, it just cycles through every time I do edge detection. So edge detection is a thing as well. So I'll show you the data converters when we get into structured text, which I'm going to look at here in a little bit. Okay, we talked about the repository. I showed you where the repository is, and that's what you're looking at here. So we've already seen this and reusing code. So again, as a developer, you can store project components, functions, function blocks into custom libraries, right? So I already added a custom library to the project, so I'm not going to do it again. But when you build your own library, you can choose to make that library open source, so users can see and edit your source code, or you can compile the library, which if you're an OEM, that's probably a better option because that'll prevent users from getting in and adjusting your library, the code that you use to develop the various components that are part of your library. So again, I don't have time to get in and show you how to build a library right now, but I will be doing that either in YouTube form or another one of these classes here at some point soon. All right, now the task manager. Okay, we looked at this a little bit yesterday, but an application can contain multiple tasks. And a task is used to schedule the execution of your program POUs. So the type of device, whether it's a drive or a module like our MCI 210 that I'm using today, is going to determine the type and the quantity of tasks that can be used for your application. And here's another big differentiator. If you're using the onboard target in our Commander, Unidrive M, Digitac, HD drives, you are limited to 2 tasks. You can have one, what's called a freewheeling task, and one clock task. Now that's not bad. I mean, if you think of a traditional PLC, I default to Rockwell stuff, but there is a main task, right? Well, yes, I can call subroutines and things like that, but most oftentimes the freewheeling task is where you're going to be doing the lion's share of your work. People assume that, oh gosh, I better have a clock task because that's going to speed things up. In my experience, it's the opposite. And I'll show you a timing diagram here in a little bit. But the reason I say that is a clock task is a cyclic task with a programmable interval, and it acts like an interrupt. So it'll make more sense when I put it on the timeline, which is the next slide. But understand that you're limited to 2 tasks with any of our onboard targets. Now, when you go to a module, like I have, there's 12 tasks. So there are 4 clock tasks. There is 1 position task, which is the highest priority. There's an initial task. We're going to add an initial task and a position task to our example project today. The initial task, as the name implies, runs 1 time on start or power cycle. So if I cycle power to the drive and the module, the first thing it's going to do is it's going to run the POU that's associated with the initial task, right? So the initial task is commonly used to include drive setup parameters, things you've taken from Connect, your motor information, your encoder motor feedback settings. The idea being that if you have a drive fail, you disconnect or unplug the MCI module, replace the drive underneath of it, and so long as you're using this, you haven't changed the motor or anything like that, on initial power up, if you have your drive parameters in this task, now the end user won't need to open Connect and load his parameter file because it's here coded into a POU that's being operated by the initial task. So that's a very typical use of the initial task, initializing variables, things like that, initial. So we're going to do that here in a little while. Then there are event tasks, right? So there are 4 event tasks that run 1 time when they're triggered. There's an error task, which also runs 1 time when it's triggered. Then there's a freewheeling, all right? Just like we have on the onboard, there's a freewheeling task here, and that's the task that we're using right now. So to get a better understanding of how these tasks relate to one another, here's a timing diagram. In this example, I have a project or an application that has 1 task, just like we do now, the freewheeling task. Well, on initial power up, it's just going to run. There's nothing interrupting it. It's just simply going to run. Now, what happens if I add a clock task? Again, the clock task has a cyclic interval that you enter the time interval. So if I add a clock task now, here's what happens. I set my interval for my clock task in this example to 4 milliseconds. So it is going to run, and it is a higher priority than the freewheeling task. So clock 0 runs right away for 4 milliseconds, and then every 4 milliseconds afterwards. So it's like an interrupt. Now, if I lay my freewheeling in there, that's what happens. The higher priority task will take time away from the freewheeling task, because this is deterministic. In other words, the clock tasks are deterministic. The code in this task is going to execute every 4 milliseconds in my example. Now, it doesn't take 4 milliseconds, as you can see. All right, so the balance of the time is consumed with the freewheeling task. 4 millisecond tick comes around, that runs, then that runs, and over and over and over. So that's a clock task. Now, as the application developer, you have a responsibility to develop the application with the least common denominator in mind, and that is the end user. As such, it's highly recommended to use development languages that are best suited for understanding by all involved parties. It goes without saying that adding program comments is a must. Now, again, I'm not the world's greatest programmer, but you should take the time to comment your project as best you can with, again, the end user in mind. So this pyramid you see here, this is something I've taken from CodeSys training. And this is kind of their recommendation as to the development languages that you should utilize when building your projects. So engineering level, at the base of the pyramid, structured text. Right? Well, we're going to find out, we're going to look at structured text next. Structured text is the most efficient language there is. It's non-graphical. So structured text can include not only drive setup things like we're going to add in the initial task, but it can also include functions and function blocks. Just because you traditionally associate a function or a function block with a visual language like ladder or function block diagram, you can still call functions and function blocks using structured text. So at the engineering development level, structured text is a good language to use. And then for maintenance staff, ladder diagram is pretty much the king. I mean, that's what most people are comfortable with. In my estimation, or in my experience over the years, I've seen a lot of people, just because of familiarity, try to use ladder to do motion control. I don't recommend that because ladder diagrams operate left to right, top to bottom. I don't know where I'm at any given time. Therefore, in my advice would be ladder diagram is perfect and preferable actually for any of your I/O, Boolean logic. It's great for handling I/O. It's also great for fault handling. You know, what am I going to do if the drive trips, or what am I going to do if somebody, or if the motor smashes into a limit, or what have you? That's a great use of ladder diagram. Then at the top of the chart, and this is what I talked about initially yesterday, sequential function chart is great for the ability for an end user to see or to locate where a potential or an actual problem is. And the reason I say that, and I'm going to show you, we're going to look at sequential function charts, The way a sequential function chart works is it starts at the top and it flows through according to the logic that you lay out. So let me just open up the final project here and I'll show you exactly what I'm talking about. And here's another thing too. I've updated Machine Control Studio since I developed this. So now it's saying, okay, well, this new version has some different libraries, right? So this project developed with this library version, well, that's where it is now, right? So the action is do not update there. I'll say set all to newest. So when I do that, it's going to update these things to conform to the version of software that I'm using. Okay. Now, sequential function chart. Let's look at that. Here's what a sequential function chart looks like. Okay? The beauty of this, and you're going to see this tomorrow when I run it, the beauty of this is it is literally going to step through these steps. This is a transition. And what that means is I cannot get out of this until that's true. It's probably better to look down here. There's a transition. So if I'm homing my motor, I can't get here unless that is true. So if something were to go wrong during operation, whatever that something is, and I were to go online, it's just going to hang right there on the step that's causing the problem. Somewhere in the code in here, and I'll show you that, somewhere that's the code for a step. Somewhere in that step, there's going to be a problem. So rather than guessing, oh man, what do I look at? Where do I go? The problem is going to be isolated to the step, right? So in my estimation, and it's very much machine dependent too, some machines don't lend themselves to this very well, like web handling and stuff like that. I don't know that I'd choose sequential function chart for that. But if you have a machine tool or something in which you press a start button and away we go, and it just repeats, this is a great language to use. So that's why I put that up here. In the end, you're going to do whatever's most comfortable for you and your users. I mean, I get that. So, but this is kind of a recommended arrangement. So now let's look a little more at structured text. Structured text is a non-graphical development language. It's very similar to Pascal and other low-level programming languages, and it is the most efficient language of the ones that are supported, of the 5 languages that are supported. It's got a low memory footprint, and I think the code executes a little faster as well. I don't have any imperial, oh, I guess I do. I have tested this and it does run a little faster. So, and there's an example of what structured text might look like. And I'll look at the project here in a minute. But so a POU that uses structured text is created using what's called instructions, expressions, operators, and operands. POUs using structured text operate from top to bottom. Now, if you've used structured text for other things or maybe other industrial machinery, sometimes when structured text, you have to include code to make it loop, to start at the top, top, go to top, things like that. Jumps and labels are supported here, but I highly discourage their use. Jumps and things can lead way down the rabbit hole, and it's very difficult to, troubleshoot and debug issues. So when you're doing structured text, you don't see a return instruction. So there, it's implied, it's implicit. So it just starts at the top and runs to the bottom. Structured text. So this is what the structured text POU components look like. So here's an if statement here. Well, I use the correct term. If, then, and end if are referred to as instructions. That's going to be important when I show you the help system next, right? If you want to know how an if works, that's going to be found in the instructions help. So that's an instruction. Now we have operators. So the equals sign here, or the equals symbol, is a comparison operator. And then pretty simple, if this is true, then do what? So there's a comparison operator. Here's an assignment operator that we looked at yesterday. Colon equals. That's an assignment operator. There's arithmetic operators, plus, minus, all the usual suspects are supported, including square root, exponentation, things like that. Constant, just like in my example earlier when I updated the preset speed using a constant of 100.0, well, that's a constant. And then the end of line character. New users typically have a little issue with that. One missing semicolon will throw out hundreds of errors. So I'll do that on purpose just to show you how to get around that. But anytime you have an instruction like this, or a statement, or expression, I should say, again, we'll use the correct terms, that's an expression, it must include the semicolon as an end of line character. So that is a typical structured text component. Help. Let's go look at help now. So help, contents. Now it says initializing the help. Oh, good, they've changed that. It used to say initializing the online help system, which kind of implied you need to be online, but now it just says help, which is better. So here is help. Now, right? So getting started, this chapter is all relative to our implementation of Machine Control Studio. Quick start, right? So here you can go through and a guided setup for an onboard project. And it just walks you through step by step, create a new project. So that's useful. That's helpful too, just to kind of get the basics underfoot. Editing the program. So this chapter, getting started, is relative to our implementation. This chapter is CodeSys help, okay, as the name implies. So let's see, if I come down here, programming of applications, okay, let's look at that. Declaration of variables, okay. So these things are all relative to CodeSys themselves. This is the underlying help for CodeSys. And if I come down here, what else do we have? Using libraries, programming reference. There we go. Let's look there. Variables, operators, programming languages. Let's look at that. Structured text. Well, that's a timely topic. Let's look at that. So expressions, so on and so forth. Operators. So this help, when you're getting started, I'd recommend just leaving the help. You notice it's in its own window. So I'll just minimize that. So that's one way of using help. There's also, let's see if I talk about that, I hope I do. F1, there's another keystroke for context-sensitive help. Now let me give you an example of that. So I'll come into a program that has, let's see. Like so. Let's say here, I don't know how a case instruction works. So I'm just going to type case. If I can spell it, I'm going to do that. Like so, right? Now I don't know how that works. I don't know what the syntax is. So I'm going to highlight it. Then I'm going to press F1. And it goes right to the help for that topic and shows me an actual example of the syntax for a case statement, else, end case. As you can probably imagine, there's a lot to this software. There's a real lot to it. And that's why we're starting here at the beginning. I want to show you around under the hood a little bit. How do you get at help? But it's all here in the help menu or in the help tool. So that's very, very useful. And I'd recommend that you leave that open while you're developing your projects. Adding tasks, right? So let's go now and we're going to add a couple of tasks to the project we started yesterday. We're going to add an initial task and a position task, right? So I'm going to go back here now. I'm going to choose, let's see here, recent projects. There we go. And that's the one I just had open, so we'll open that. No, I don't want to change that. Okay, so here's our project. I didn't save the code we added today, which was not a good idea, but anyway. So if I want to add a task, how do I do that? Well, once again, it's right-click. Can I add a task from here? No. So again, follow the hierarchy. I can only add a task to the task configuration. Right-click, add object, task. Now you might recall when we used the setup template yesterday, there was a whole list of tasks there. I could have added all my tasks right then and there. But what I don't like about that is by default, it creates a POU for each one of those tasks that I add. And I inevitably end up going back and getting rid of those POUs. So I prefer to do it this way. Your mileage may vary. So I want to add a position task right there. And okay, we'll say POU name position. Create POU for the task. Okay, that's fine. We can do that, right? Actually, no, I'm not going to create a POU for that task. I'm going to uncheck that. So we're going to create a task, but not a POU. We'll do that later. Click OK. Right? So here is the interval for a position task, 1 millisecond, right? I can't get any faster than that, but I can go up to 200 milliseconds if I would like. So there's my position task. Now I'm going to add another task. And this one is the initial task. This one is okay. I will create a POU for that because I want to use structured text for that. So we'll click OK. So now I have an initial task, and now I get a POU that's associated with that initial task because I elected to do that. So that's the process of adding tasks to your configuration. Now that we've got those tasks, I'm going to show you a typical use for an initial task. So I'll save that project. I should have opened, and by the way, that's something you can do too. You can have multiple instances of Machine Control Studio open as well. But I'll just go ahead and open the other application instead. There it is. So as I mentioned earlier, a use of an initial task is commonly to set the drive up. So I'll do that. Right, so I'll look at the POU for my initial task. Right, so, oh, I don't have an initial task here. Oh my goodness, what happened there? Okay. Well, that's interesting. I thought I did that. Well, at any rate, I'll just add one. Initial structured text. There we go. All right. So there's my initial. So what this is typically used for is this is where I would go in and enter things from Connect software. So let me go back to Connect and show you what I might add. My motor settings are in menu 5. So again, assuming that the drive has failed and I put a new drive in, what do I need to know? Well, I certainly want rated current, rated voltage, number of motor poles. So in the initial task, I'm just going to add these things like this. So that's menu 5, parameter 7. Once again, the data type, it's 32-bit, but notice that this has a resolution of 3 decimal places. So let me go and add that to the initial task. So I would put comments here and things like that, but pressing the F2 key will bring up the input assistant right away. So here, what I want is a variable from the CT-UNIM library. I want menu 5, parameter 7. Now, just like before, there's 2 versions of this, depending on whether I want to use the LReal or the integer version. I'm going to use LReal, like so, which to look at it now, you wouldn't know the difference. But I'm going to say colon equals 1.5000. Just like that, semicolon. And so on and so forth. You know, if I were to do this more cleanly, I would probably add some comments up here too. I would probably come up here, and comments are preferenced with a double forward stroke, like that. So I would say drive parameter tab operator value. So that's the parameter. There's the operator. Value. And I would come up here. And do something like that. Whoa. Oh, it's a comment. So make it a comment. Right down the line. Everything that would be normally required to be edited or added using Connect software, I would include as part of that initial file. Voltage, motor poles. You could add all of your auto-tune parameters too. I could add everything in light blue. That's probably what I would do. The only problem with that might be if the motor were to fail. If you replace the motor, well, some of these things would have to change, so you wouldn't necessarily be saving time. But anyway, I would add things from menu 5. I would add things from menu 3, which is the encoder data. I would come down here. What's my device type? And these parameters that are highlighted in light blue. I would include those things. Digital I/O. I would go through and I guess you don't really need to. Yeah, you don't really need. I wouldn't include these things. Mainly it's motor and encoder type, those two things. And also, I'd also include the IP address for the drive, and that's a little different. If I go to menu 24, that's the active IP address. Well, in Connect, it shows up as a traditional IP address would. But you'll notice the data type is a double integer. So what you would need to do, and I have developed a function to do that, is convert this octal notation to decimal. And basically you feed in the octets as you see them there, and the binary math runs inside my function, and it spits out a decimal number. So that's also important to put in the initial file, initial task, if you don't want somebody to have to use Connect or the keypad to enter that manually. So the initial task is commonly used for things just like that. Now the position task, of course, is where we're going to put our motion program, right? So tomorrow, when I show you the solution project, we're going to walk through all of this, right? I'm going to show you the sequential function chart. We'll show you what these actions are, right? And things that you would find necessary when developing a real Machine Control Studio application. We're going to end there for today. Does anybody have any questions?
Going back to the timing charts, there are 4 available clock
Yes.
routines. What happens when you have multiple clock routines? Like, say, multiples that execute at 4 milliseconds, like your example showed.
Good question. And the question from the audience was, what if you have multiple clock tasks? You set those up in ascending order, with clock task 0 being the fastest, quote unquote, clock task. Clock task 1 would need to be a different interval. So if clock task 0 is 4 milliseconds, clock task 1 would need to be 6 milliseconds, 8, something like that. So you set them up in ascending order with higher, slower times for each clock task, and they are treated, clock task 0 is the highest priority clock task. Does that make sense?
That makes sense, yes.
Yeah. Rule is, I would avoid using clock task unless you absolutely have to. When would you ever use a clock task? Well, I would use a clock task if it were important to go out and take a snapshot of motor position, maybe. Or if I wanted to deterministically, every 4 milliseconds, I need to do this. In other words, it's something that has to be executed at a given time. Other than that, I would avoid clock tasks. Any other questions? Alex has his hand up. Let me see what that is. Hold on here. Chat. I'm not sure. Alex is asking, can you also do a phase shift with the clock task? Are you referring to phase control? Like a master follower kind of thing where they have to keep in time? Is that what you're referring to, Alex, or what? Can you expound on that just a little bit, please? I'll give you a second there. Hopefully you can still hear me. Okay. I mean, if what I'm saying is what you're asking, no, that would not be a good use of a clock task. That would be handled differently. Oh, here we go. The starting time of a clock task. So clock task 1 times 0. Yeah, I think I just answered that in the other. Oh, no. No, what would happen is, because clock tasks have higher priority than freewheeling tasks, clock task 0 is going to have a different time interval than clock task 1, 2, and 3. Right? You can't have clock tasks with the same interval. So clock task 0 is the first one to run, right, for 4 milliseconds. Clock task 1 might have a 6 millisecond tick. So it's going to run after clock task 1. And the more clock tasks you have, the less time there is for the freewheeling task because of the prioritization. So hopefully that answers your question, Alex. If it's not, please chat again. Anything else today?
I had a question. When you were going over variables, you said they reset every time the program restarts.
Yes.
Is there a way to declare persistent variables that'll...
Absolutely.
Okay.
Yep. Well, I'm going to show you that tomorrow. Yes, persistent variables and global variables also. We haven't talked about that yet, but yeah. Here's a global variable list right here, but if I come up to application, add object, persistent variables. See that?
Okay. Yep.
So, right. Yeah, there are some things that you want to persist. So they would be added to a list of persistent variables. Yes, good question. Anything else? Okay. Well, if you think of something and you'd like to ask me a question, just send me an email to training.cta Charlie Tango Alpha at mail.nedec.com. All right. Thanks again for attending today. And tomorrow we're going to be going through this project that you see here, and I will demonstrate how that works. So thank you, and we'll see you tomorrow.